I think we dropped off at 14. Something like this. Abdullah Abdul Baqi.
Yes, mister.
16. We just started 16.
How does reflection differ from reflection and diffraction?
Yes.
C.
Read it.
Reflection affects all types of mechanical waves, but refraction and diffraction do not.
Why that? Why reflection and diffraction does not affect all kinds of mechanical wave or all types of waves? Give me some examples of waves that refraction and diffraction does not affect.
I don't memorize them, Mr. All.
طيب. Did you read the rest of the choices?
Yes.
Read all of them again.
Reflection is only process in which the wave does not continue moving forward.
Mhm.
Reflection is the only process that involves a change in the wave.
Mhm.
Reflection is the only process that changes the direction of the wave. Reflection affects all type of mechanical waves, but refraction and diffraction do not.
So we didn't read the last one. Reflection. Reflection is the only process that changes the direction of a wave. So you choose C. Your answer is C.
D.
D. Bear with me. Let me pick someone else to see if this is right or not. Abdullah Mubarak. Abdullah Mubarak.
Yes, mister.
Allah, do you agree with your classmate or friend Abdullah Abdul Latif? He said that the answer for question 16 is D. Do you agree with that?
Sorry, mister, I just joined, so
Mhm.
I didn't read the
Re-
question.
Read the question again. Tell me what is the answer.
Yeah. How does differ from refraction and diffraction?
Mhm. Read all the choices and pick one.
Yeah, reflection is the only process in which the wave does not continue moving forward. Reflection is the only process that involves a change in the wave. Reflection affects all types of mechanical waves, but refraction and diffractions do not. Reflection is the only process that changes the direction of the wave.
Mhm.
Uh, is it C, mister?
Mhm.
Is it C?
What is your answer?
C. Reflection affects all types.
C. Okay, just bear with me. Let me pick someone else. Faisal Mahesh. Faisal. Faisal is here. Ibrahim Amr Sulaiman. Ibrahim Amr. Ibrahim Amr Sulaiman. Ibrahim Amr. Muammal.
Yes, teacher.
Muammal, what's the answer for question 16? What is the answer for question 16?
Uh, I think A, Mister. Reflection is the only process in which the wave does not continue moving forward.
Yes, the answer is A, because all of this is wrong answers. Let me read them one by one. Reflection is the only process that involves a change in the wave. That's not true, because diffraction and refraction and reflection, all of them change the wave. Okay, in refraction it changes the direction and speed. In diffraction it changes direction and spread out. In reflection it changes direction or bounce back. Reflection affects all types of wave, but refraction and diffraction, I can't remember any kind of wave that refraction and diffraction does not affect. All of them, reflection, refraction, and diffraction, affect all kinds of waves. Letter D or the answer D. Reflection is the only process that changes the direction of a wave. That's not true because that happens in refraction and happens in diffraction. Refraction, there is a change in the direction of the wave, and also diffraction, there is a spread out, or which is a change in the direction of the wave. So all of these are wrong. The only one is A. The right answer is A. Reflection is the only process in which the wave does not continue moving forward, because in diffraction and refraction, the wave continues to move forward. But in reflection, the wave bounces back in the same medium, So that's the difference between reflection and diffraction and refraction. Thank you, guys. Let me pick someone here for the next question. Muhammad Ramadan.
Yes, Mr.
Question 17, Muhammad.
Okay. For refraction to occur in a wave, the wave must, I think,
Yes, answer C, enter a new medium at an angle. Because if it enters a new medium at right angle at 90 degrees, it will not refract. It must enter a new medium with an angle, so it will refract. So the answer is C.
Mr.
Yes, I hear you.
Can we get is the sheet in the WhatsApp or the Coursera?
The Coursera, I will upload it. I didn't upload it yet. I will upload it today, right now, after this session. On Coursera, you can find it there.
Okay, thank you.
Navjan? Ali Kamal? علي كمال المرزوق. علي كمال المرزوق. سعد اليامي.
Yes, Mr. Yes, Mr. I'm here.
Sa'ad. Okay, so question 18.
Okay, in reflection, when a wave travels from one medium to another, it
In refraction.
travels in positive direction.
No, in opposite direction, this will be reflection, but we are talking about refraction. Refraction, not reflection.
Okay. So it will be always in the same direction.
Always moves in the same direction. This is not right, because refraction, the wave changes its direction. انكسار, اسمها انكسار أصلا. Refraction, it moves its direction. When the wave travels, When the wave travels from one medium to another, what happens? When the wave travels from one medium to another, we know that the speed of a wave depends on the type of the medium. Like light wave, for example, in the air has a different speed from vacuum, has a different speed from glass, from water, and etc. So the wave has a different speeds in different mediums. So when the wave in refraction travels to a new medium, from one medium to another, what would it change? Speed changes, for sure speed changes. Okay? In refraction or in any kind of wave properties, when the wave travels to a new medium, the wave changes its speed because the wave enters a new medium. Thank you, Ustad Liam. Go up. Abbas. في كتير غير ولا ايه؟ عبد المجيد. ما شاء الله غير كتير أوي. عبد الله العبد اللطيف. Okay, Abdullah, question 19.
What is one property of a wave that determines how much it will diffract when it encounters an obstacle?
What wave property will determine the amount of diffraction? Is speed of the wave, amplitude of the wave, polarization of the wave, of wavelength of the wave.
Wavelength.
Wavelength determines the amount of diffraction. Thank you. Abdullah Dahilan,
Yes, Mr. A.
question
Which
20.
wave will be diffracted the most by an obstacle? A. A longitudinal wave. B. The wave with the highest amplitude. C. The wave with the longest wavelength. D. The wave with that strike a solid barrier with zero speed. I think, Mr. It will diffracted the wave with the longest wavelength.
Yes, because we just said in 20 the property, the waves property that will affect the amount of diffraction is wavelength. That's why here we have C. The wave with the longest wavelength will diffract the more. Question 21. عبد الرحيم عادل. عبد الرحيم. Adham.
Yes, miss.
Adham, question 21.
Suppose two waves collide and the temporary combined wave, the result is smaller than the original waves. What term best describes this interaction?
Suppose two waves collide and temporary combined wave that result in a smaller than the original one. So the amplitude gets smaller. What term best describe this interaction? When a new wave is formed and you have a smaller amplitude, what we call it? Generally, what we call it when two waves collide, Adham? When two waves combine together or collide, what we call this?
Diffraction?
No, call it interference. When two waves combine or collide together, we call this, or interfere together, we call this interference. But we have two types of interference. We have constructive interference and destructive interference. Which one is described here in this question? When you have a smaller wavelength or a smaller wave, the combined wave is smaller than both of the original waves. What is the kind of interference here? Is it destructive or constructive interference? Adham?
I think it's B.
Yes, it's B. Destructive interference, because in the destructive interference, the combined wave or the result wave will be smaller in the amplitude than the original waves. But in constructive, that forms a larger wave, not a smaller wave. Thank you, Adham. أحمد القناص. أحمد متعب القناص. أحمد متعب القناص. علي صبري. طيب أحمد موجود. Question 22, Ahmad.
The formation of a standing wave requires to travel the wave for a long distance or consecutive interference between two waves have slight difference in frequencies or the tractions and differences occur at the same time in the wave or emphasis between incoming and reflected waves.
The formation of the standing wave requires what?
A.
Traveling of a wave for a long distance? No, this is not right. Standing wave, the wave that has a shape or it seems not moving to the left or to the right, but seems standing still. This is a kind of a standing wave. It requires what? To have a standing wave, you need what? You don't need a traveling wave for a long distance. We perform this kind of wave in a wire or a string, if you remember that. That is 1.5 meters or 2 meters length.
C.
It's what? See? Not see, the refraction and diffraction. There is no diffraction. And there is no refraction in the standing wave. Standing wave, you remember what a standing wave is? That one that has a node and anti-node. Bear with me, let me see someone else.
B.
I don't like this. You have to know the answer or just not randomly pick choices. Ali Yusuf, Hilal. Ali Yusuf. Ali Yusuf, Hilal. Ali. طيب. Hassan, Ramadan.
Mr.
Yes.
Faisal.
Mr. Zir. I called
Yeah.
you Faisal previously. I'll come back to you. Hassan, Ramadan.
Yes, Mr.
Hassan, what's the answer for question 22?
The formation of a standing wave require. This is B.
Faisal. Faisal.
Yeah.
Answer for question 22.
The formation of standing waves requires constructive interference between two waves of slightly different frequencies.
No, this is not what we need for a standing wave.
And wait. Okay, the formation of standing waves refers traveling the wave for a long distance. The direction of action occur the same. I would say interference between incoming and reflected waves.
Yes, the answer is D. The answer is D because interference is said we will send a wave down the string and this wave will be reflected in itself. That's why we have an incoming and reflected wave, and this means we have two identical waves, the same frequency, the same wavelength, the same speed, everything is the same. Two identical waves will interfere together, and that will, at specific frequencies, we will have a standing wave. So interference between incoming and reflected waves, this is the answer for this one. Thank you, Faisal. Thank you, Hassan. And thank you, Ali. Nas. طيب علي Hilal is absent. Ibrahim Adil. Ibrahim Adil. Ibrahim. Ibrahim Anwar still absent.
Yes.
Okay. 23.
A sound wave is an example of surface wave.
Sound wave is example of surface wave. Surface wave is the wave that travels on the surface of the ocean, of the water, any water. Is a surface wave. But sound wave is example of what?
The transverse.
Longitudinal wave. Sound wave in the air, it travels as a longitudinal wave. Longitudinal wave. Because we said sound wave will travel as a series of compressions and rarefactions. Explain that a lot. طيب إبراهيم ربيع. إبراهيم ربيع. إبراهيم ربيع. معاذ 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 أحمد. I don't know if you're absent or you can't hear me. محمد عبد الباقي.
Yes, Mr.
What question 24?
In which medium does sound travel the fastest? C, Mr. Air.
Yes, in which medium does the sound travel the fastest? In air, ولا salt water, ولا fresh water, ولا cast iron? So to the speed of a wave, we said previously the speed of sound wave or any wave increases from air to from gases to liquid to solid. So the speed of sound in the air is the slowest, 340 meters per second. In water, for example, it would reach 1,500 meters per second. In cast iron, it would reach to 4,400 meters per second. That's because the particles of the solid material is tightly packed together, and that's easier for vibration to transfer faster because there is a lot of particles compacted or bunched up together. So that's easier for sound wave to be, or vibrations, to be transmitted from one particle to the other particle. That's why the speed in the iron is faster than the speed in the water is faster than the speed in air. So in which medium does the sound travel the fastest? Not in air, Muhammad. It's in cast. Yes, in cast iron. Sonar requires equipment. Let me take someone. Muhammad Ayman الملهم. Muhammad Ayman. Maaz, I'll come back to you. Muhammad Ayman, are you there? Do you hear me? I didn't hear from you. Brother Muhammad Ayman. Maaz, answer this question. Question 25.
Sonar movement sound waves into deep water and measurements.
Send the sound wave into deep water and measures of what? Read all the choices, Amaz. Read all the choices.
Refraction of the transmitted wave, only the director of the reflected wave, the time delay of the returning echoes, interference of the transmitted and reflected waves.
So what the sonar equipment measures?
A, refraction of the transmitted wave.
No refraction. No, they are not measuring refraction. They need to know the distance, or they need to know if there is an object, how far it is away from them. So they will send a wave, and then they will receive it again after reflection. It will be reflected from a whale, for example, or a group of fish in the deep water. So they will measure the time taken for traveling and coming back, and from knowing the time and the speed of a wave in the water, they can know the distance traveled. So they can determine the direction and the distance of the target they are looking for in the deep water. So what they are actually measuring to do that, which one is right, Mars?
E, interference of the transmitter reflected waves.
No, not interference. They are not going to measure interference. They are going to measure, I said, you need to know the time taken for the wave to leave and then coming back. So when the wave leaves the radar or the equipment, they will start the stopwatch until the wave comes back again and hit the equipment, the receivers in the equipment, and the time will stop. So they are measuring the time taken between the sending of the wave and receiving it again. This is called delay time. Okay. So the time delay of the returning echoes. So they will measure the time taken for a wave to leave and come back from an object or reflected back from an object. This time, and knowing the speed in the water, in the salty water, from this information, the time taken and the speed, they can know the distance, how far the object is away from them. This is the same technique that dolphins use, and also the bats use it. Lots of animals actually use it. طيب 26 محمد السعد Thank you, Muaz. Muhammad Saad.
Yes, Mr. I am here.
26.
A piano, a violin, or a guitar uses the resonance of wooden soundboard to
Why would they use the soundboard? When there is a guitar, there is a string. The sound comes out from a string. Yes. Why they use this
limit
box?
Standing waves, mister. Limit standing waves.
It's a standing wave. The wave that's produced from guitar is a standing wave. They are not limiting the standing wave.
Amplifying the sound, mister.
Amplifying sound using resonance. This box creates resonance and amplifies the sound that is produced from the string. Because the sound produced from the string is weak sound, you can't hear it. So they need to amplify it, make it louder. They will not change the pitch, they will not change the frequency. They will only change the loudness of this sound. So they will amplify the sound. 27. Abdulaziz Al-Hilal. Abdulaziz Al-Hilal. Murtada.
Yes, Mr.
Okay, Abdulaziz. 27. Abdulaziz, do you hear me? An ambulance siren.
Yeah, Mr. I'm reading the question. See, Mr.
Do you have to read the question before you answer it? I will read the question.
Mr. I said see.
Did you read the question loudly for us? I didn't read the question.
Should I, Mr.?
Yes, you should.
Okay. Okay, Mr. So, an ambulance siren sounds different as it approaches you than when it moves away from you. What scientific term would you use to explain how this happens?
Yes, an ambulance siren sounds different as it approaches you. Why is that? That's because of what? Like a train coming closer to you and the train sound or the pitch of the train sound seems different when it comes to you, and then it will be different again when it passes you. That is because of what?
Mr. I don't know, but it's either A or C.
No, not A nor C. It's D, Doppler effect. Doppler effect explains the difference in sound pitch when something getting closer, or when there is observer and sound wave getting closer together. The sound pitch will be higher because waves are bunched up. But once the sound wave passes you, like an ambulance, for example, siren, so that's the pitch of the sound will be decreased because of the waves are spread out after passing it. This is called Doppler effect. We have explained it before. If you attend this session with us, that's called Doppler effect. 28. Usama Firas. Usama Firas. Usama. Saad Khalid Al-Husseini.
Mr. Osama here.
Okay, Osama. Question 28.
When a sound source approaches you, the pitch you hear is? Mr. Is it D?
D, first higher and then lower than the pitch of the source when stationary? No. When a sound source approaches you, the waves are bunched up, or the waves get closer together. That's why you will hear a higher frequency, or the wave that you will receive it will be higher in its frequency than the original wave if the object was stationary. So you will hear a higher pitched sound. Okay, so what happens here, the pitch you hear is higher than when the source is stationary. This is when the waves approaches you. This is Doppler effect. Again, this question is related to this question, which is Doppler effect. طيب 29. سعد خالد الحسيني. سعد خالد الحسيني. الناس دي كلها غير علي كمال المرزوق. سعد خالد absent. نفجان absent. محمد أيمن الملحم absent. إبراهيم الربيعة ربيع absent. إبراهيم عادل absent. علي يوسف الهلال absent.
Here teacher. ربيع.
ربيع here.
Mister, I'm here.
كمان علي موجود. طيب.
علي المرزوق.
Okay. Rahim, I want you to answer this question 29.
Okay. Which part of the ear amplifies the vibration from the sound waves?
Outer ear ولا inner ear ولا middle ear?
I think D, both A and B.
Both A and B? I don't think it's D. I'm not sure of that. I think it's the middle ear, not A and B. It's middle ear. Where is the drum and ossicles? The three bones and the drum. Those are amplifies the sound wave. So this happens in the middle ear, especially the drum, ear drum. So the sound wave is amplified in the drum. Last one, Ali Kamal Marzouk. That's the question, Ali. So we can leave the decision. The part of ear that sends coded nerve signals to the brain is
the inner ear.
Yes, it's the inner ear. Yes, the cochlea, specifically the cochlea. So the answer is the inner ear. Thank you guys for listening, and I will upload this revision sheet. You have another questions for the rest, which is electricity, and I'll upload also the PowerPoint for these 2 chapters on Coursera. You can find it today in Coursera. Thank you guys for listening, and have a nice day.
Thank you.
Have a nice day.